All right, so go back to the question we were working on yesterday. Okay? The same one that we were working on at the end of class. All right, so we had this question about propane, right? We got rushed at the end, so I want to go back to it. Now, if you forgot how to write an equation, you still have your blue charts. You can still use them. But remember, you can't use your what? You get your periodic table. You don't get your what? Oxidation sheet. So propane is a formula in the question, right? You still get that kind of information. I'm never going to expect you to write a hydrocarbon because that's not part of our curriculum, and we're not going to make you know how to do that. You've got to remember that propane reacts with what in a combustion reaction? You always add what to it, even if I don't tell you that. You always add oxygen. And what were the two products again? Water and CO2. And it doesn't matter the order. Most of the time I tend to write CO2 first, but you can write water first, it's fine. So when you do that, yesterday we talked about how do you know that you're going to need a balanced equation. How many compounds were in this question? There were how many? There's more than one. You had propane, which was here, and you had oxygen. That's what told you needed a balanced equation. You had two compounds. If you think about the 5 questions you just did on the quiz, how many compounds were in all 5 of those questions? There was only one, okay? So if you read like question 1, it said, what is the density of carbon dioxide? How many compounds is that? Carbon dioxide is 2 compounds? 1 compound. All right, what is the volume of nitrogen gas? That's how many compounds? 1. It doesn't say nitrogen gas reacts with anything. Nitrogen gas doesn't decompose. It doesn't say nitrogen gas with anything. It's only nitrogen gas. Okay? But this one goes on to say propane combusts with oxygen. The other thing we talked about yesterday you have to remember is it said you had the same temperature and pressure. Is that an actual temperature and pressure? No. So, like on your quiz today, I said STP, or I gave you an actual number for the temperature and pressure. Is same an actual number? No. So if I said same, could you plug in a number in this equation? Would you know what number for pressure and what number for temperature if it says same? No. If it says same, I didn't give you anything. If you go ahead and write 1 and 273, I'm marking it wrong, okay? I'm not giving you any points because I didn't tell you what the temperature and pressure is. You can't put 1 in. Is everybody okay on those 2 points that we talked about yesterday? Okay. Now, I know everybody was making jokes today about balancing equations, but we should still be okay with this. We have how many C's? 3. So we put a 3 there. How many H's? 8. So we put a 4 there because 4 times 2 makes 8. We have 4 and we have 6. So 4 plus 6 is 10. So we put a 5 there. Now, this is the new piece that we're going to work with all day today or till the end of class. It's a volume-volume ratio. When we did this before, we did mole-mole ratios to change compounds. So, same concept. So our given data goes on the top line. So 0.350 liters of propane. So when we wanted to change compounds, we did this with a mole ratio. So whatever was on top went where? To the bottom, so it would cancel. And when we were doing this, we had moles of whatever we wanted. But this time we have volume. And we would go from moles to change the compound, right? Well, this time, instead of having a mole-mole ratio, we're just going to use what's called a volume ratio. And this can be in any volume unit. It can be in liters or it can be in milliliters. It doesn't matter which one, okay? So we're just going to go from liters to liters because is the temperature and pressure changing in the problem? No. And what I tell you about all of our problems, is the temperature and pressure going to change? No, it's going to be the same. So you can always use a volume-volume ratio. So we're changing from volume to volume so we can change compounds here. So what compound did they ask us for in the question? They said, what volume of oxygen? So we're going to change from propane into oxygen. So volume-volume ratio, just like mole-mole ratio, where do we get the numbers? The coefficient. Okay? So anytime you have a volume-volume ratio, the numbers come from the coefficients. So what coefficient is in front of O2?
5.
And what number is in front of propane? So all you do is put the coefficients in just like you do any other time. So multiply the numbers and you have your answer. What did we say that was yesterday? 1 point what, Marissa? 75 liters of oxygen. Okay? Now, that's all there is to working a volume-volume ratio. It looks just like a mole-mole ratio, except we use volumes. It's that easy. The hard part's usually writing the equation. Writing that piece. Drawing that should be pretty easy. Okay? So, let's try another one. So, assuming all volume measurements are made at the same temperature and pressure, what volume of hydrogen gas is needed to completely react with 4.55 liters of oxygen gas to produce water vapor? All right? Are you writing it or not?
Yes.
Okay, so I need to wait.
So how do you know if that's the ratio because it's all volume?
All right. When you read it, did they give you a temperature and pressure? And did they give you more than one compound? Those are the things we're going to look for.
H gets it too, right?
Mm-hmm. All right, are we there?
Yes.
All right, so when you look at that, all right, Tiffany said, how do you know that this is a volume-volume ratio? All right, so when these are all mixed up on the test, how are you going to know this? Because I'll be honest, Tiffany's question is one that causes huge issues on the test. This is one of the most missed questions on the test. Volume-volume ratio problem, and the next one up there on the board, number 5. People do number 5 wrong just because they don't get it, all right? Because it's hard. People get put out with it, and they're like, screw it, I just get it wrong, all right? Because it's just hard. It puts everything we've done all semester long into the same question, and so they just get it wrong because it's hard. But this one's not hard. They just forget how to do it, all right? So what in the question is going to tell you, oh, dang, this was a volume-volume ratio. I should not have lost 7 points on this question. I just forgot how to do it.
Has two, yeah.
It has what?
Has two gas elements.
All right, it's got 2 compounds. All right, so when you see 2 compounds, that should tell you I need a balanced equation. Okay? That's one thing. What else does it say in there that's going to tell you, oh, I need to do that? Okay, there's no temperature and no pressure, so that means I cannot use a formula. That means I'm going to need a T-chart. Okay? Those are the two things that I should recognize. There's no temperature and pressure, so I'm going to need a T-chart. And there's two compounds, so I'm going to need a balanced equation to fill in my T-chart. Those are the two things I have to recognize. Okay? If you can get those two things out of it, you should be okay. So, how do I write the balanced equation? What do I notice in it that jumps out at me? It says, oh yeah, I know how to do this. Well, what does it tell me is produced?
Water.
Okay, how do I write water?
H2O.
H2O. All right, it's produced from what?
Hydrogen gas.
Hydrogen plus oxygen, all right? So, what do we know about hydrogen and oxygen? Okay, so I put 2's on them. Is it balanced? What's not balanced? Okay, so how many O's are here? So how do I get 2 here? All right, how many H's did I make?
4.
So how do I get 4?
2.
Fabulous. All right, so we already said there's no temperatures and no pressures, so we have to use a what? So I'm going to draw a T-chart. What always goes on the top line of my T-chart? Whatever I've got for my data. So what do I have? 4.55 I heard. And what's the unit? Liters of oxygen. Okay, so where does liters of oxygen always have to go? Bottom. Liters of oxygen. Where does liters of oxygen have to go? At the bottom, so it'll cancel. That's not what I meant to ask you. I already did that one. All right, so what am I trying to get to? All right, so in order to get to hydrogen, I have to do what? Use a what? A volume ratio. So this is when I'm going to put what on top? Okay, so if I'm putting hydrogen on top and I'm changing my compound, what has to go here to change it? Liters. All right, so where did we say our numbers were going to come from if we were going to change compounds with a liter-liter ratio? The what? Balanced equation, the coefficients. So what's in front of hydrogen?
2.
And what's in front of oxygen? All right, so that should be what, 9.1?
Yeah.
Okay, 9.1 liters of hydrogen. And that's what you do. You think you can try one on your own? Okay, you've written 2, so you should have some samples. So now just try to work this one. Okay, try to work that one. You might need your reference table in case you don't remember what happens with water and sodium. Okay?
Do we get this on the final exam?
You'll get, not that one, you'll get an identical copy. It'll be on that old, like, recycled paper. It'll be in booklet form, and then in the middle it'll be a giant periodic table.
Okay.
It'll be
Everything here is gonna be on.
identical.
Okay.
This is downloaded from the state website. Periodic table that you're using is identical, except it's twice as big. It fills 2 full pages.
What?
What is base mean?
Don't worry about it.
Okay.
What's the
What?
Those are all equations.
Oh, thank you. All right, let me make sure you have the right equation, because everybody should have had time to try to figure it out on their own. Na plus water. All right,
Yeah, water plus.
what kind of reaction was it? All right, single displacement. What'd you get?
H2 plus NA. Plus.
Did you get that?
Yeah.
Wait, figure that out.
All right, in single displacement, if you look under single displacement, you have M plus H2O, and you get MOH plus H2 on your reference table. So I put M is Na, and then OH. I'd add a +1 and a -1, so they cancel out, and then H2. Right? Because M is Na, so I put Na where the M is, and then OH. That's a +1, that's a -1, so they cancel out, and then plus H2. All right, and then you need to balance, and then finish it. I'll give you a second to balance it, and then draw your chart. All right. So, what did you put for the balanced equation? How many H's do we have over here?
H's?
Yeah, how many H's?
Oh, wait.
There's 3. There's 1 and there's 2. So we need to put a what on this one? Make it even. So we've got 4 now. So what are we going to put here? So that means how many O's? How many O's? How many NA's? And then 2. All right. So what did you start your chart with over here? 15.6 liters of. Okay. What goes on the bottom? All right. What are we putting on the top?
H2.
Liters of H2. All right. So what goes beside liters of H2? And liters of water. So what do we get?
7.8.
We got it? Okay. I want you to do those two.
Oh.
I'm going to give you a sheet for homework.
Oh,
Gosh darn. Yes.
Of course you would.
And ammonia is what? Nope. NH3. And H3, remember that one from the test.
Ow.
Come back and bite you.
Oh, this is more correct.
Yep, just those two. You don't have to write them. I've got a practice sheet for homework. It's got questions just like this. Just write the equations and draw your charts. And then we're going to see if we can't get a head start on tomorrow.
Isn't that an acid?
What? NH3?
Yeah.
It's actually a base.
Maybe two.
NH3 is a base. It's a weak base. You can tell bases because they feel slippery if they get on your hands. So if you've ever cleaned with ammonia, you'll get it on your hands and it'll feel slippery to you.
Ooh,
That's why soap, when you get it on your hand, it feels how.
slippery.
So what do you know about it?
It's
It's base.
What does the acid feel on your hand?
It doesn't. It doesn't have any feel.
Just burns.
Can if it gets in a cut.
Oh. Wait, why? What is it?
It's the hydrogen ion.
Won't you- Remember, ammonia's NH3 and it's produced.
So ammonia would be after.
Yeah.
Last year.
Yeah.
She's not. Why?
She's sick.
She was in this like 104 feet. She's done.
Wait, who?
Because her phone told me that they told me yesterday that she wasn't feeling good, so she went in her office and checked her temperature. She had 104 temperature, so she was
That's how fast I'm going. 65. Yeah. So you got to
Oh,
What's that? You press.
set picture of everybody.
Yeah.
You just have to be in here, it's like you die.
All right, what'd you get for the first one? You should have had time to get that one worked.
15.
So ammonia is what? Ammonia is, and it's produced, right? What's it produced from? Nitrogen, and do we know anything about them? So we put 2's on them, right? All right, we need a 2 there and a 3 there. Everybody good with the equation?
Yes.
All right, so drawing our chart, what goes on top? So 45.7 liters of hydrogen. What goes on the bottom? Liters of hydrogen. What are we asked to go to? Liters of NH3. So, what number goes here with liters of NH3? And what goes with liters of hydrogen? So what'd y'all get? 30.4?
Yeah.
Liters of NH3. All right. You got number 2 done, or do I need to be still for a minute?
I got it done.
Done.
Done?
I don't know if it's right.
All right, so potassium reacts with water. So this is very much like the last one. So potassium reacts with water. So what'd you get?
KOH.
And then plus H2, right?
Who did it?
All right, so we have 2, 2, and 2. All right, what do we start with? 35.6 liters of water. What goes on the bottom? Liters of water. And what are we going to? Liters of hydrogen. Hydrogen has a what? And water has a,
2.
so what do we get? Questions about how to do that? No. All right.
I thought everything was balanced at first.
You thought which one was balanced at first?
Everything was balanced at first.
Okay. But do you see that there's 3 H's on the right? Okay. All right. The last new kind of problem.
No.
Shuckerdoodles.
Sorry.
You gotta
This
put
is
this
cold as there
on.
was a
You gotta
tree.
put them on.
You do not have a quiz wrong. Guys, a test will be next week. It'll be our benchmark.
We have another quiz.
Oh, you said it's gonna be our benchmark.
Probably not. Honestly, probably not.
You said it's gonna be our benchmark.
I told you earlier in the week, I'm not creating another test for the sake of giving you another test to make Ms. Curry happy that I gave you a benchmark test. So our gas law test is going to serve as the benchmark test. So even if we're done with this tomorrow and we review on Friday, I will teach new content Monday and our benchmark test will be whatever day the benchmark is. Okay? I'm not going to create something new for us just so that we have another test. Okay? So
I like
our
the way you
benchmark
think.
test will be our gas law test.
Like the way you think.
All right? Now, this is the last type of gas law problem. This gas law problem is going to combine our PV equals nRT and stoichiometry. So we're going to combine balanced equations and volume-volume ratios with PV equals nRT.
Oh, shit.
Now, these are the longest of the problems. There are 2 of these on the test out of the 11. If you can't do these are 20 points on the test. Okay? I'm just telling you ahead of time.
20 points all together?
20 points altogether. There's 2. They're worth 10 points each. Okay, now,
20 points each. I was ready to say.
no,
60.
they're 10 points each. So it's a total of 20 points. Come on, stop. So there's partial credit, but a lot of times for some odd reason, I get people who just leave these blank. I don't get it. At least try. Now, there is nothing really for me to give you for notes here. That's just so you got a title. Now, I'll give you a minute to write this down, and then I want you to see if you can tell me what's different about this question and the one you did on the quiz today. Because it looks very similar to what you did on the quiz today. All right, we caught up? All right. So tell me how this question is different from what you did on the quiz. Because most people look at it and they think it's the same.
Yes, it has, two compounds and it gives you, pressure.
Okay, I like the first part of the answer better.
Combust and producing.
Okay, it's got the word combust and it's got two compounds. All right, the STP that's right here, is that different from what was on the quiz today?
No.
No. So that's the part of Tomas's answer I didn't like. The rest of his answer I did like, okay? It uses the word combust and it has two compounds, okay? The two compounds plus the combust equals a balanced equation, okay? Which means you're going to need a volume ratio. Now, you can work this entire question and not use a volume ratio. You're going to get the wrong answer, which is what most people do. That's the part they do wrong on the test.
Right. Okay, so because it's given two compounds and they're together, makes them volume mass thing.
Yes, that's what makes it different. So, we're going to set it up exactly like you did on the quiz today. You're still going to use PV equals NRT. Now, every year people go, Ms. Wall, can we use Big M? The answer is yes, you can. You can use Big M. The problem is you're going to need, instead of a two-step chart half the time, a four-step chart. You can work it that way. Some of you will figure out that way. And if you do, more power to you. Just show me the work on your test. I'm incredibly bright. If you show the work, I can follow it and figure it out. The only time I can't is when you just don't show me the work. And again, I'm not Sherlock Holmes. I'm not going to spend 15 minutes trying to figure out your work to see where the numbers came from. So if the answer is wrong and I can't follow it, I'm just putting down minus whatever and moving on. But if you show me the work, I can follow it. Even if you make a small calculation error, if the work is there, I can probably figure it out. All right? So the pressure is 1 atm, temperature is 273, and R is 0.821. Nothing is different than it was on the quiz, right? All the differences come in the volumes and the moles here. So the volume I gave you was 5 liters of what? CO2. I want to know how many grams of what? Of what? Propane, which is C3H8. I would not expect you to know that. It's just a typo on my part, and I forgot to put that in the question. Okay, but I would never expect y'all to know propane is C3H8. Now, this is what makes this question different from the ones you worked on the quiz. On the quiz, I gave you find volume of CO2, and I wanted a mass of CO2. But on this problem, I'm giving you a volume and a mass of 2 different compounds, okay? These are different compounds. That's what makes this question different from what you worked on the quiz, okay? That's the only thing that's different. That's why you need the balanced equation, because you're going to have to change with the volume ratio. Right, Jaden? Get off the phone.
Right there.
Pay attention up here. So you with me, okay? Or you be giving me a bad rap tomorrow, yelling about I didn't teach you how to do something. All right. So we got propane. What's propane? C3H8, right? I told you I wouldn't make you know that. All right. Plus, what do we do to it for combustion? And then we get what 2 things? Okay. And we've balanced this one numerous times. So I'm just going to put 1, 5, 3, and 4 there because we've done that multiple times. All right, so we've got our balanced equation for when we need it. Now, is everything in the right units? Yeah, so do I need to change anything?
Wait, I thought you needed to change the N to moles.
Okay, but do I have the N right now? No, so I'm just going to go ahead and plug in to PV equals nRT because pressure is atmospheres, volume is liters, and T is temperature, right? So I'm just going to plug in. So PV equals nR and T. So pressure's 1, volume's 5, N we don't know, R is 0.0821, temperature's 273. So how do I get my N?
You bring over the,
Not yet.
you bring over the other side.
Yeah, I got to bring over 273 and the 0.0821, right? Got to divide like Justice said back there. So N equals some small number. All right, so 5 divided 22.4. 0.223. 0.223 moles. Now, this is the part where students have a hard time. That's moles of what?
CO2.
CO2.
Oh.
Sorry. I don't know what to tell y'all. It's moles of CO2. That's because I like you best. I'm going to get somebody sick, it'll be you. All right, it's moles of CO2. So, if that's moles of CO2, is that what they asked me for?
No.
No, it's not. So, I have a problem, right?
Yep.
So, I've got to change it. Now, I have two ways that I can solve this. And I did this intentionally to show y'all the old way, and then I'm going to go back and I'm going to show you the new way. There's tissues there in the corner. All right? If I have it this way, I did it this way to show you the old way. So, I can take my 223 moles of CO2, and I can do what? I need to get to grams of something, right? So I can go from moles of CO2 to moles of propane at the bottom, to grams of propane at the top. Okay? That's the old way. Some of you will like that way better. Okay? Nothing wrong with doing it that way. That's the way that a lot of people will gravitate towards.
What's the easy way?
Okay? There's no less number of steps. That's one way to do it. Okay? Now, the other way to do it would be to use the volume-volume ratio. Okay? Now, would be to back here, where it's CO2, would be to take the 5 liters of CO2 and change it from CO2 back here to liters of propane back here. So propane has a 1 and CO2 has a 3. So what's 5 divided by 3?
1.6.
What?
1.6.
1.6?
Yeah.
1.6?
What does that say?
5, it's got a 5, a 1, and a 3. Okay? So, instead of using the 5 right here, I had to put in the volume of 1.6. Okay? So, I'd have had 0.0714 moles of, instead of having CO2, I'd have had C3H8 here. And then I could just do a 2-step chart and go from 0.0714 moles, I could go moles to grams.
Wait.
I didn't even see her do that.
Wait,
Where's
that other number?
714 moles.
Okay, if you had decided way back here to go ahead and do your volume-volume ratio, okay, you would get 1.6 liters of C3H8.
So we can't do that.
Yep. You can go ahead and do a volume-volume ratio here and go ahead and get rid of CO2 altogether. And this would be your propane. And then CO2 would be gone and propane would already be converted. And then you would get moles of propane, which would be this.
Oh, because it's liters.
It'd be-
Replace it.
That's right. You would have replaced it with liters of propane. And then you could just go there. And then your mass of propane is what? 36 plus 8. That would be 44. Okay? This would be 1, 3, 1, and 44. Okay? It just depends on which way you want to do it. You get the same answer. You just choose where you want to make the conversion. Some of you will prefer to do the volume ratio up here first. Some of you will skip it and be like, dang, I forgot it. And then do the mole ratio at the end. It doesn't matter which way you choose to do it. It works the same. Okay? Now, we're going to work with that tomorrow because I know that's a lot of steps. Now, for homework tonight, though, I want you to practice the volume ratio. So, I got you 5 questions. And the beautiful part is, I even wrote the equation. So this is like, I don't want to hear that I didn't do my homework like you all, but check it. And remember, if you want to do test corrections, they'll be here this afternoon or any other kind of makeup work. Don't wait till the last minute. There's only 5, and I wrote the
I
equations.
was just asking if we had to do all of them. Dang.
Yes, Jay. You make it sound like I gave a ton of homework. Okay.